Outspoken Engineer, episode 2, season 2. We've brought in an expert, somebody that's been in the industry since '94. He knows exactly what he's talking about in certain areas, and he has been solely responsible for training many engineers in the industry for some time. We're here with Ben Bartle-Ross from Mitsubishi Electric. Let's do this. Hello, Ben.
Hi there, Jacob.
Great to see you today.
Thank you for the invite. It's lovely.
We've had a bit of fun playing around with a wall-mounted unit.
Yeah, you said it.
You
said you could do it in 3 minutes. You had to step up.
Tune in, and we can watch this in another video. But you'll find out if I actually did it or not. It was quite a challenge, and it will be posted soon. So let's look at your history, Ben, because although you're sitting there wearing a Mitsubishi uniform, you have some resume. Let's start back from, was it 94 when you got into the industry?
Yeah. So after leaving the Royal Signals, I joined York International.
Okay. And Royal Signals, so as in?
As a soldier, yeah.
Oh, phenomenal. I didn't realise that, Ben.
Oh, that's my hidden history.
Okay, so hidden history. How long were we?
Coming out.
Yeah. How long were you in the Royal Signals for?
Oh, not long. It was about 6 months, and then we had a slight incident involving a very large log on my leg.
Okay, right.
Therefore, got medical discharge.
Okay, so you left the Royal Signals and got. Was there a reason you joined York? Was it York International?
Yeah, York International looked like a fantastic opportunity as an apprentice. So I started on the shop floor as a grunt, shall we say.
Okay. What were grunt duties at York between 94 and... You were there for 5 years?
Yeah, so I started off as a wee little apprentice as a fitter, working on air conditioning systems for chillers and things like that.
Yeah.
And by the time I finished, I was involved in things like the prototyping of the chiller system for the Trident submarines.
Oh, blimey, okay.
Yeah, and then I became a design engineer for York International.
Interesting.
So I got off the shop floor, shall we say.
Understood.
Started using my head a bit more.
So when you were on the shop floor as a little grunt, the people that were training you and teaching you, what were they like? Were they maybe the word is militant? Were they hard old school engineers as such?
Definitely hard old school engineers. You know, it was right 6 degrees of superheat. Not why. That's just what you need.
Understood.
Yeah, it took me a long time to actually find out why.
Understood.
Yeah,
Understood.
A lot of bro science. Does that make sense?
Yeah, I get it. I'm with you.
Especially on the shop floor.
Okay, so there was no in between. It was very black and white and very, well, I would call old school.
Yeah. Do as you're told, don't ask why.
Understood.
Yeah.
Okay, right. So in '99, you made a jump to a company called Space Ray, which doesn't have anything to do with NASA or spacecrafts. It has something to do with gas.
Yeah. So I left the AC industry altogether and started getting involved in doing radiant tube heaters and plaque heaters. So basically burning gas.
Is this something like a Resner-style unit we would see in a B&Q?
Yeah, definitely.
High level?
That was were the competitors. Yeah.
Understood. And for 2 years, I'm going to assume that you didn't like burning gas, or you thought this isn't interesting enough, or
I saw it as being a limiting industry.
Okay.
Is that a fair point? You kind of get into something, think, this is interesting. Right, this isn't going anywhere.
Okay.
Right. And then wasn't actually necessarily intentional joining Mitsubishi. I got headhunted because I kept on stealing jobs off Mitsubishi.
Right. Smart move, Mitsubishi Electric. Smart move.
No, I understood enough about air conditioning and I understood enough about radiant heating to work out how to, shall we say, push a job in the right direction, especially big aircraft hangars and things like that.
Right. So you've got sales. You're a hidden salesman. Or you were a hidden salesman?
I've always been a hidden salesman. So I've never been involved in sales, but lots of indirect sales.
Understood.
Yeah.
Understood. So direct sales meaning selling directly. Indirect sales, believing in the product and making sure people understand the product and how the products work to enhance the sale process.
Yeah.
Understood.
And the Space Ray was a very small company. There's like 18 people in the entire company.
Right.
So it's one of those jobs, where you wear whatever hat's required. So I was pre-sales, I was after sales, I was with the design engineers, and I helped load up the truck at the end of the day. It was whatever's required, sir.
So there was enough for you to realise what you liked and what you didn't like?
Yeah.
Okay. So you were headhunted by Mitsubishi Electric in 2005. And when you joined Mitsubishi Electric, what were they like as a company back in 2005?
Small.
They were small.
Small.
Right. It's more than 18 people?
No, bigger than that. A big jump on that front. But yeah, it was myself and a gentleman called Ben Webb who was involved in doing pre-sales for the whole of the south of England.
Okay.
I think we were doing about...
Right, okay.
Numbers now was getting towards...
Right, okay. So they're small in today's comparison. In 2005 was a lot of money. So you were still a large corporation, but significantly smaller than you are today.
Yeah.
Okay. So from 2005 to 2014, you were pre-sales tech. So we would phone Ben when we would need some information on a product we would potentially install. Is that right?
Yeah.
So when you call the manufacturer because you need some advice on a certain product, you would answer that.
Yeah.
So you were the knowledge base of the product.
Yeah. Making sure that what you're wanting as your solution is actually going to give you what you want. That's a sense check, but also help with the whole design procedure.
So you would deal with consultants, you would deal with business owners, you would deal with engineers sometimes.
Oh God, yeah.
Sole traders,
definitely.
partnerships. The full chain of people that would buy your products.
Yeah. I mean, in idea, it would be just the person who's involved in designing whatever we're going to do. Yeah. But it's not the reality. The reality was I've dealt with homeowners. I've dealt with consultants. I've dealt with architects. I've dealt with the engineer on site who's trying to work out why this bit of pipework's not going for this wall and what we can do to make sure it works.
Right, okay.
Yeah, it's whoever's needs the help.
In 2005 to 2014, as pre-sales tech, was this 100% air conditioning?
No.
Okay. What else did you do pre-sales tech for if it wasn't just air conditioning?
It was fresh air, so air handling units.
Okay.
At the time, Mitsubishi was also involved in doing PV, so photovoltaics.
Back in 2005?
Yeah, we're involved in that, yeah.
Okay.
And then the bubble burst when the the big feed-in tariff stopped and we pulled out of doing PV, so at which point I didn't need to know about it anymore. So moved on to the next job.
Right, okay. So they were the sort of three elements: ventilation, air handling units, air conditioning, and solar PV.
Yeah, and we were doing beginnings of the heat pumps.
You were doing beginnings of the heat pumps. So there were talk of heat pumps back in 2014.
Yeah. So the very first versions we were playing about with, so it wasn't to do with residential. It was all big commercial stuff.
Is this on a chiller bias kind of stuff in reverse, or it was actually...
It was let's take a ducted unit. Let's throw away the coil. Let's throw away the fan. Let's get a tube-in-tube heat exchanger and stick a pump on it and see what kind of water temperatures we can get.
Oh, I see. So you were playing around.
Yeah. This is connected onto a VRF system. Because people were saying, actually, why can't I get hot water out of this thing and produce hot air? Why can't I get hot water out of it? Well, yeah, you can, but you can only get about 45 degrees.
So is this, did this transition to the hydro boxes? And what do we call the Mitsubishi alternate? Do we call that the hydro? Do we call it hydro box as a...
For the VRF range, it's the PWFY.
So the
the hot, the 70 degrees one.
So the ducted unit, which has been converted, playing around, has transitioned into a machine which bolts onto the VRF, which produces hot water.
And it's got its own little refrigeration circuit inside of it because we need to get temperatures up to 70 degrees.
High temp.
For commercial work, yeah. But that's not where it started from, not by a long way. And people want hot and cold as well. So they were wanting hot water and cold water, and we very quickly learned that cold water on a VRF system was quite dangerous.
Right,
because people didn't put proper safeties in place, and we turned water to ice.
Understood.
So we learned, it was all part of that learning process. And to say that Mitsubishi doesn't, during the design process, we don't make faults. Of course we do. We not faults, failures, but that's part of the learning process, making mistakes.
Completely agree.
Yeah, and that's the whole process of learning.
What's amazing is the fact that not just you mentioned the failure, but you can, if you fail 10 times and you learn from them 10 failures, if you hadn't tried it in the first place, you would never have got anywhere.
Yeah.
So when you say from 2005, 2014, you were messing around with ducted units, there's been a lot of failures and a lot of learning, and you transitioned into a product which is on the market at the moment.
Yeah.
It goes to show that actually sometimes it's very easy for us to turn around and say, well, this product quite clearly hasn't been tested. Well, the proof is kind of in the pudding there because that certain product has been tested for some time because it's been a lead up of events to bring out it to market.
Yeah. I mean, when the Ikedan unit came out, I wasn't necessarily expecting it because I got my head around how we do hot water off a VRF system for commercial. And then this thing turned up and said, here's an Ikedan. Oh, that's a Mr. Slim unit with a plate heat exchanger in it. Right, okay, so this isn't where I expect it to go. Well, we've looked at the market. It's not commercial. It's residential. It's the big market that needs it. Right. Okay, let's get my head around this. And then it was learning about what's required to make a heat pump work in a way that a heating engineer would understand. So make it work on things like S plan and Y plan.
Right. Okay.
At which point I went, what is S plan? What is Y plan? What on earth are you talking about?
And that leads into the heating element, engineer being introduced into a heat pump, which is a refrigeration circuit.
Yeah. You can't try and make a whole industry change to suit the way an air conditioning unit would like to work.
Gotcha.
Instead, you've got to change it, man, to suit what the engineers need to work with. So trying to make it engineer friendly.
Understood. And that probably leads on to 2014 to 2023.
Mm-hmm.
You're a senior technical trainer.
Mm-hmm.
So what is your job role?
So it's
Official job role.
so training in general,
Okay.
but it's customer training, it's staff training as well.
Okay.
But it's all trying to keep ahead of the learning curve. You know, everyone expects you as a trainer to just know everything. Yeah, so
Okay.
I do need to go keep myself educated. So part of that, I'm also involved quite often with some of the product development that goes on within Mitsubishi as well.
Okay.
That's me being nosy. I'm a nosy so-and-so. That's what I do for a living. So when
Okay.
somebody turns around and says, I hear you've got such and such, I better know about it.
Understood. So although you're direct facing to consultants, engineer training, a vast range of training, you actually need to, excuse the pun here, have your finger in many pies
Yes.
to ensure that what you're saying can be backed up by evidence and by what you know
Yeah.
rather than what you've heard.
Yeah. Yeah.
Understood. So going on to your training. So something that I'd like to understand I wouldn't even necessarily say 2014, obviously since 2005, is the transition from air conditioning being a mechanical industry, standard, and I mean standard, I know this might be a bit foreign to you, Ben, but a standard inverter, fixed speed compressor,
Okay.
fixed speed fans, to inverter compressors with inverter control fans from PCBs. So how has training changed for that? Because engineers have had to change significantly. And I was in that transition in 2007 from, checking a contactor to now and having to do inverter.
Yeah.
Were you involved in that transition?
Yeah, because it is about an education thing, because you've always got people in that situation who've got the right attitude and behavior in that they want to learn. Otherwise they wouldn't be coming to see me. If they weren't interested in learning, they wouldn't bother going on the training course.
Sometimes though, Ben, we have to, right?
Yes,
To maintain our service records.
That's right, exactly.
But I suppose if you're an engineer in the 80s learning, you were coming at the back end of, well, I'm not really going to get into this inverter malarkey because I'm not going to be doing it for much longer. I'm going to retire. But there was a transition from, if you're an early 90s engineer, having to jump onto the inverter. Bam. It's a standard now, by the way. So it's something which, we all deal with. Every unit is, I'd say 95 of all units is an inverter.
It makes sense because it's a more efficient way to do that job. You want to be able to, have a unit that ramps up and down to suit the requirements of your area. It makes much more sense than the on-off situation we used to have.
Okay.
Yeah. Okay, when you get to big stuff, the on-off situation still works because you've got a big buffer tank to try and deal with things like chillers.
Correct.
But for what we're doing for normal air conditioning, should we say, comfort air conditioning, inverters make sense. It's a more efficient way to do things. But you're right, I get where you're coming from. What I found is we've got more engineers who are interested in trying to gather information so they can make a correct decision. And that's changed now because you can get, stick a laptop on the side of a VRS system and you can gather that information to work out what your decision needs to be rather than going around putting gauges on systems and putting your hands on pipe work. Don't get the wrong idea. I still go around putting my hands on pipe work. Yeah.
Hands up, I still do.
Yeah. I just like to back it up with, see, I told you, I stick it on a laptop and go, this is the data I felt with my hands.
Yeah.
Here's evidence behind it.
Well, you saying that leads on to something that is really, I know we touched on it earlier today. Our engineers today, there are good sides and bad sides, I believe, to this. Our engineers today better off being good at splits and multi-splits and VRF, one or two things, or 1 to 3 things, directly very good at it. There is a book, Jim Collins, Good to Great, and one of the theories is called the hedgehog concept, more business element. And what it is great businesses focus on certain things, 1 or 2 things only, rather than certain businesses, when they do grow, he describes it as the fox concept. They cross the road and they decide to try and eat everything. And unfortunately, they don't actually eat anything because they kill everything and they just leave it. Whereas a hedgehog says, wait a minute, I'm going to get to A and B, and no one's going to stop me. So being an engineer focusing on VRF, maybe VRF only, what I'd like to get your view on is, if you were to be an engineer, if you're an engineer with 2 years experience, would you say, well, actually, I want to focus on VRF only, master it with a service checker, or would you be in the boat of, well, actually, you'd be better off understanding elements of chillers, air conditioning, splits and multi-splits, and air source heat pumps? What boat would you sit in? Or would you like to sit in if you were to train again?
I prefer to see somebody who's done a little bit of specialism.
Okay.
So, yeah, just specialise in one. However, nobody gets that privilege. It's not the position you can have anymore, because the customer phones up and says, my system's not working. Okay, you go to site. Your next problem is, why is it not working? So you need to understand how the VRS system works. You need to understand how the BMS system works, because it might be the BMS that's causing you the problems. Yeah, there's other things on site that could be part of the problem. It's the same as saying, oh, all I do is electrical work. No, you don't. You have to get your head around the other things that are
cameras,
connected to it.
electric gate, CCTV.
Yeah, I think I would rather know aspects of a lot of things than just specialise in one.
But then what can happen with that attitude of specialising in one is saying, no, I don't know what I'm doing. You need to call someone else. And I know certain manufacturers, some of their engineers, I'm not sure how Mitsubishi work, but we've worked with another manufacturer, and some of their engineers will not work on heat pumps. And unfortunately, there is a slight arrogance and frustration with the heat pump guys that, and they're usually the longer server engineers that know VRF, and they've got 20 years experience and they're working on heat pumps. And some of the younger engineers are actually told, don't try and do heat pumps because you're not wearing our t-shirt, working on them.
No, it's
How's training? How's obviously not so much pre-sales, but because I'm sure Mitsubishi Electric as a company have had to diversify to ensure what you've just said, to wear lots of hats, have had to adjust things. But in terms of training, you're obviously asked a lot of questions about different products. Is there frustration sometimes from engineers? Frustration meaning you can see there's a lack of education, maybe because they haven't enough time on equipment.
Yeah. That does happen. I've seen it happen before now. Yeah, where people get that frustration, especially if somebody comes in and says, well, you work for Mitsubishi. Yeah, but most of the time we're doing VRF or DX, same for the pre-sales team.
Yeah.
And somebody comes in and says, right, I'm interested in with these chillers. All right, okay, I need to push you another team. No, I want to talk to you because it's all part of the same project. And they're going, no, I don't know enough about that particular side of things because we have another team that specialises in it.
Understood.
Yeah.
Understood.
But I still feel that everybody who's involved in that side of things should have an appreciation enough so they can start that conversation. And that's tough because you end up wearing a lot of different hats. But still, how about this? We'd like somebody to be a ambassador, not the right word for it. I'm trying to think right for it. A hero in that particular field. Does that make sense?
Yeah. So and it goes back to specialisation. You specialise in one or two aspects, and you absolutely nail it.
Yeah.
Rather than,
but you don't need everybody in your team to be that hero.
Correct.
Yeah.
Yes.
I need in each team. I need one of them is an absolute hero with air handling units, or an absolute hero with chillers. Does that make sense? To bring that level of understanding.
The curveball to this, Ben, is when you have AHUs with fridge circuits inbuilt. Versatemp is a fine example where you've got very small old school style units with fridge circuits into water. We've actually got an incident at the moment where it's very difficult and tricky for us to work on it because you need to be a BMS engineer, a fridge guy, and a mechanical guy.
Yeah.
So Ben, you would prefer to be a specialised engineer if you were to become an aircon engineer?
I don't know. I think I'd want to know the aspects of it. Can't I be an expert in everything? Like, is it just one or the other? I have to specialise in one thing, or can I specialise in multiple things?
So in 10 years' time, when you're laid in a bed and you're plugged in, like Neo from the Matrix, where they just upload a skill, that's probably
because I've taken the red pill.
Because you've taken... Is it the red pill? Is it not the blue pill? No, it's the blue pill, Ben.
Oh, is it?
Yeah, it's the blue pill.
Red pill keeps you in the Matrix, where you're not like in the simulation.
Exactly that.
Got you.
I would have thought after so this weekend we lifted two times 650 kilowatt clean moving chillers onto a roof. Perfect job. Ben was there filming. We've actually done an AI podcast because AI is coming. Would you not want to be a chiller engineer? Chiller engineer?
Yeah.
Or was it too dirty for you?
No, I think they were quite clean, the engineers that were on site. Well, they haven't got their hands on it yet, but it seemed all right, to be fair.
Okay.
That's interesting because then you end up with trying to know about hydronics. to even start understanding the water side. And that's another specialization. And quite a few people involved in VRF don't necessarily want to get into hydronics. Not saying they won't do it, just a preference I hear is a bit of sort of feedback quite often.
Okay.
But in my head, this still comes back to the idea that we only got 4 basic bits to any refrigeration circuit. If you take it back to the basics, you said to me earlier on today, keep it simple. Yeah?
Keep it simple, stupid.
Exactly. We've only got 4 basic bits. All these stuff we've been talking about, with the exception of the PV.
The challenge is, Ben, is although it's 4 basic principles, you've got water circuits, filtration. There are different elements to factor in. Again, it goes back to the education and understanding of learning on the equipment to truly understand how it works.
Yeah. But that's why I like taking it back to the basics, because what am I really bothered about? With all the hydronic side of it, what I'm really bothered about is, have I got the water flow?
Yeah.
Is that water nice and clean? Because then I can transfer the energy from that refrigerant circuit off to the water to do whatever I need to do with it.
So, Ben, your take on this is the perfect attitude to have. So engineers which either focus on 1 or 2 things and become great at them, or want to be the jack of all trades because they want to wear loads of hats and be lots of mini heroes, having an open mind and having the right behaviour and attitude towards a subject,
A willingness to learn and accept you're never going to stop learning.
is everything.
Yeah. You're still going to get that day when somebody sends you a site and they say, look, just make it work. And when you get there, somebody else has fitted one bit and they've left and done their bit. They fitted the
That's
coil.
it. Yeah,
Let's
of
say an
course.
air handling unit. Yeah, that's all working. The fan's working fine. And the refrigeration engineer, he's come along and he's fitted the DX part of it, and that's all done. And nobody's done the handover to the customer, and you're put in front of it.
Yeah, that happens a lot. You've got lots of people which denounce responsibility, and they assume someone else will pick it up. But that's something which goes on in every industry. It's not just air conditioning and HVAC. I've got a few views on training that I want to run past you. So if I want to look at some negatives of training, since I've been training since 2007, I don't believe it's changed a lot. And this isn't pointed at Mitsubishi Electric. This is general air conditioning training. We're here to talk HVAC and aircon, and I've got a few pointers which may make things better in the future.
Go for it.
I believe spending a day in a training centre is a waste of time. And I say a waste of time because I believe you're actually probably getting 3 to 4 hours of pure education, because there are a lot of distractions and usually have some really good lunch. Some companies have gone to online training, which I'm not a fan of in long stints.
I think online training is actually I think it's more difficult than like being in the classroom, because there's for me, it's just so much more distracting. If I'm in a classroom, I'm there. Obviously they're willing to come there. It's not like school where you have to go. It's like you are focused in that room. I just find online training a lot more difficult.
Your phone goes, you can answer your phone, and someone can walk in the room, etc., etc. And the other thing with that is, if I go to the gym or I go for a run, okay, I don't do a 3-hour run. I wish I could, but nobody trains for 5 to 8 hours on themselves. It's very hard to stay focused.
I agree.
I believe a 3-hour training session is the solution.
Okay, I'm going to throw this back at you. When I go to the gym, I'll hit it hard for 45 minutes to 1 hour.
Fantastic.
Yeah.
That's the way to do it, then.
That's what I think people should do with online training. That's the whole point of online training, is you do a bit. Take it on. You don't learn for that long. We think we're really good. I can do 3 or 4 hours. No, you can't. About 25 to 45 minutes,
Is the
I'm
amount of
starting to lose concentration.
information you take in.
That's the whole point. Dip in, dip out.
The
take on
only
information, consolidate
the only
it.
sort of curveball back at you, Ben, is being challenged and asking why. To have them questions, you do need interaction from a Ben Bartle-Ross.
Yeah.
So if there is a Ben Bartle-Ross, and it is online training, and it's for a short amount of time, and you are being able to ask a question or two, I think that's a really good way of improving.
Yeah. So I mean, that's why we do the web. So within Mitsubishi, as you know, we have this blended learning approach.
Yeah.
It's constantly changing, by the way. This is not written in stone by any means. Okay. So the idea being is that online training beforehand, and then we do a webinar, which is consolidate what you've been going over, test you a little bit, and it's your opportunity to really question the trainers and go, yeah, but what about this? What about that? What about this? I've read this, and how does this work? That's the opportunity. We're doing more and more as we move forward towards hands-on.
Okay.
But the advantage we're going to have with the hands-on training is all those basics that you do in a classroom, as you say, Ben, you do those beforehand. So when we get into the hands-on, it's right, risk assessment, right, everyone sorted on that. You know where the fire escapes are. There's where the toilets are. Right, let's get on and let's install some equipment.
Yeah.
And then once you've installed and done a really beautiful job of it, I'm going to go and break it.
Understood.
Okay.
And now break it a bit more. You work on it,
Yeah.
break it a bit
That's
more,
cool.
work on it. And it's an ongoing thing. And it goes from a moment of, I don't know what this unit is, to I know this system inside out because I've broken it. There's nothing like for an engineer to break something.
And you've
then
nailed
fix
it in smaller stints rather
Yeah.
than a long day and you've only got 3 to 4 hours worth of
Yeah.
learning out of an 8 day.
But I have a problem. My problem coming my way is I want 10 engineers to learn how a VRS system needs to be installed correctly.
Mhm.
Okay? In a hands-on situation, that would really mean I really need 10 VRF systems in one training room.
Okay.
That's not really possible, is it?
Anyone out there with 10 VRF systems in their office, shout out to Ben Bartle-Ross. He needs you.
So,
I understand. I get it.
so stuff that we're thinking about
Okay.
is what else could we do?
I think the live working environment. Great book. I'm not sure on the author. How is talent created?
Mhm.
Education builds up 30%. Hands-on approach is sort of 50, 60%.
Mhm.
And the remaining sort of 20 to 10% is usually willingness and behaviour.
Yeah.
So the live working environment is probably really important.
Yeah.
Okay, what we're not discussing is the logistics behind booking and training, and
Yeah.
that's something which we can be naive to because we're not involved with.
So,
Um,
give you an idea what we're playing about with potentially, and you
Yeah.
see what your emotional response is to this. VR.
Okay.
Yeah, like Oculus Quest, like
Yeah. First, sounds great. Yeah, sounds very good. Watch this space, I think, for yourselves because it can either go two ways: very, very well, or very, very bad.
I know.
There is
I know.
nothing in between
I
with
know.
VR.
yeah.
So this,
It's either a really bad portrayal of training, or it works out very, very well.
yeah, that's what I'm trying to work out now.
And then
It's my
and then
world.
after VR, it becomes augmented technology or projected technology,
Yeah.
where you can actually pop up a projector and see Ben in your office and go through
Things
things
like
in
that.
person.
Yeah.
Okay.
Yeah.
I think VR is a good start though. Like you can if you develop it in like
Well,
augmented reality.
what it brings, Ben, is it brings diversity and also looking into the future rather than being stuck in your ways. Because
Yeah.
sometimes that's in the right direction and that's where we need to be.
yeah.
And if a company is going in that way, it'll have a lot of failures, but it will eventually nail it.
And that's the thing. I don't want to do it just for the sake of doing it. I want to do it because it's going to work, because it's going to be helpful. It's going to make things easier for the engineer.
Understood. What's your take on? We had an interview with an American, Josh Griffin. We have the same issues with technical training and issues, and as engineers would like to complain about, as you know we do. Engineers are worse than school children, and I'm just as guilty as that. One thing that we suggested would be a roadshow. So Mitsubishi Electric have a bus with Ben Bartle-Ross on, with lots of equipment. Instead of doing a roadshow like other manufacturers do, which is direct selling, why can't you do some indirect selling to say, well, actually, we're going to pull up at your office this day. We will train all your engineers and we'll go through this range of equipment.
Yeah.
It turns my side with my engineers is into there's an element of fun because they're here, the bus has pulled up and they're learning for half a day. You would then go on to another company and do some training.
That's an interesting idea.
Do you think it would work?
Can you drive a bus?
It's definitely below his pay grade.
Yeah. It's nothing I won't do. I think I can see the advantages to that. I definitely have something like a roadshow, but definitely one of the things we've been talking about is this idea that when was the last time we went out there and just literally stood in front of a customer and said, just ask us whatever you want.
Yeah,
Mm.
it's a direct Q&A, which
Yeah.
we never really get the opportunity to do.
Yeah, just go stand there as a manufacturer and say, talk to us. What do you like? What you don't like? Give us
Some,
just
you know
all
what?
the questions.
You know what's really amazing like that with this? It's like a form of counselling where I might struggle to get through to Mitsubishi Technical as an example,
Yeah.
and the person I might not have perceived what he said was correct, and it builds frustration. And sometimes you speak to other companies and they would say, well, they're no good, or another company's no good because their support is bad. But believe it or not, sometimes, Ben, it's because they just need to stand in front of someone and just vent.
Yeah.
And then you say, understood, we've had a few issues. We've actually improved those processes. And this is the answer. And then sometimes it's,
Yeah, it's stopping and listening sometimes. That's sometimes all it takes, actually.
and you probably get this training where you would hear,
Yeah. I'm front line.
yeah, you
Definitely
are.
front line. And if somebody's going to vent, they'll quite happily vent at me. And that's fine.
This is where the RAF signal in has probably helped Ben a along the way. So looking at the HVAC industry over the last 20 years, you've been in it since 94, so you're there. Does something stick out as one or two of the most standalone changes? You know, as in for you to say, yeah, that was big, even if it was a failure, or not so much just with Mitzi, just in general. You know, we've gone big VRF, we've gone big chillers, we've gone big GWP, big R32, HVRF. Has there something which stands out as this has gone big and it's brilliant?
I think one of the things that stands out to me is how things go around in circles.
Okay.
How some things we've got rid of certain technologies and those technologies have come back. This is this constant ongoing learning curve. So yeah, VRF was a big deal. HVRF, big deal. We're going back to using water again. It's almost like having something between a VRF system and a chiller. And guess what? I've done a lot of time with chillers and then VRF. So it's interesting to come back together.
So your suggestion, I know Mitsubishi Electric have products, and I'm sure others do, but the combination of VRF technology with chillers.
Yeah. This whole thing of this attitude, we've got to keep on improving and changing. You can't stand still.
So your answer to the question really is how common the change and as we go around in a big circle. And although that you sort of think, well, we're going backwards because we're going around in circles. It's a saying.
It's always an improvement.
But it's an uphill spiral. Yeah. It's a spiral which is consistently evolving, and although it's the same product as such, it's being adapted to actually being better.
Yeah. And the other big thing for me is the Internet of Things. That's probably one of the biggest step forwards.
Is this Internet of Things meaning migration into AI, or is this Internet of Things meaning the way we can control and adapt units?
I don't see them as being different.
You see them as being the same thing?
Yeah. It's the same handshake.
Okay.
It's the same information.
Just with well, Ben, what's your view on Internet of Things versus AI? Are they both monitoring and learning and creating?
Well, I think AI monitoring wise, I think you can give it parameters like rules to go by, like the AI, the machine learning rules to go by. So, like for example, like you said about is it Spain or something that they're capping places AC
for air conditioning over 27 degrees. Yeah, they did. Do you know about that, Ben? Yeah. Okay.
Yeah. So that for AI, that would be parameters that you almost program in before the AI is, like, say, installed into a system.
Okay.
And then the AI will continuously live by those laws, basically. So I think
versus the Internet of Things.
The Internet of Things, like you can program it as a computer and can have it connected to the Wi-Fi, but it won't make smart decisions like AI.
And your views on that, Ben?
I agree.
Okay.
But that's the whole point. It's data. So it's what you do with that data. That's the Internet of Things is the way to get the data. The next thing is what you do with that data. How smart can we be with that data? So you're talking about that 27 degrees over in Spain as being the max. In that situation, so in capping situations, well, you can get the system to start learning and going, actually, I'm going to make it cooler at this time of the day so that we don't have that problem. I don't have the issue. I won't be getting near those temperatures.
So going on the Internet of Things and AI, so the video that is going to be released shortly on my views on the positives and negatives of AI in air conditioning. One of the positives was, shoot me down on this if I'm wrong, but VRV and chillers, as an example, or splits, they have PCB boards which control the units. They are preset, let's call it by an Internet of Things, or preset out of the box to run a certain way. But when certain things don't work properly, meaning there is a gas leak, they will protect the system rather than create information to say, whoa, wait a minute, I'm not running the way I was told to run. Something isn't right. And it'll either adapt and try and get itself to work the way it needs to, or it'll actually say, we've got a problem here. Let's look further. Is that how you'd understand AI?
That's exactly what I want AI to do. I want AI to do some forms of preventative maintenance. I don't want the kit to ever go wrong.
So you want it to learn from its mistakes, and you want it to tweak.
Yeah. So the whole point, so the bigger picture here, what you really want is to have a really good engineer in the room and say to him, when this unit goes wrong, let's say I got a discharge temperature problem. Yeah. Why would it have occurred? What's the problem? What are you looking for? Because when I know what you're looking for, I can start plugging those parameters in.
I see.
Yeah,
Okay,
so
I see.
I mean, simple things. Let's go for a real simple one. Is that filter dirty?
Yeah.
How
okay.
hard is that? How hard is it
What's-
to actually tell
what's-
somebody that the filter's actually
No,
dirty?
you're right. And what's amazing, Ben, is if there is a self-cleaning function on a filter, which, believe it or not, is coming. I know some brands have it, but it's not common practice.
No.
Just to let you know, my take on this, and that is, the Dartford Tunnel, there's no longer people opening barriers. It's done by computers. I believe that should be the case with filters. I really do. Because our engineers should be trained with humans. We've got the best learning processor in our brain. If there is a self-cleaning filter, the AI will make the decision to say, filter dirty, clean filter, right?
Opposed to like a normal system, like say without AI, it's more like, yes, there's a problem. That's it.
No.
Worse-
So what?
worse than that.
It's
Well,
worse
yeah,
than that.
well,
So
But AI will be like, there's a problem, but this is what I'm going to diagnose it at.
Correct.
This is how it can be potentially fixed.
Yeah.
I think
where
me
to
with
look.
a self-cleaning filter is probably a step or two, is reactive to what the AI is producing.
Yeah.
But it will produce, because BMS does touch on it slightly sometimes, where there's lots of internet things you can plug in to get answers. But I think AI is more of a broad spectrum. But you see them as actually AI and internet of things working together.
Yeah. But also the other thing is in my head about the Internet of Things side again is it doesn't look like it's quite right. Right, before we flag anything else up, let's go and have a look at that data. So it's been flagged up as a problem with the system potentially.
Yeah.
All right, let's get one of our engineers, just have a quick look at that. Yeah. Bring it up on via our maintenance tool, which you can do, and have a look and see how that system's running and go, actually, do you know what? I think I know what the problem is.
Understood.
Right beforehand. Yeah?
Understood.
But it's having that, but still I still want to have good engineers. I'm after that. I'm not
Understood.
trying to get rid of engineers by any means. In fact, I
Well,
need better.
Ben has just hit a really interesting point. So one of the negatives, watch the video, that I have said about this is with AI, and I've not mentioned Internet of Things, but if we're going to assume they're the same thing, it's one of the disadvantages. People are going to lose their jobs. Well, unfortunately, I think it will, but it will give us as human beings a chance to enhance ourselves to control the AI. Because it will take jobs, and the reason it will save on call-outs, because sometimes companies, big FM providers and small FM providers, they make money on going to call-outs for units not working and the filters are blocked, and then they'll make the money on the call-out, and then they'll make the money in the preventative works, the maintenance. Whereas the AI will actually say, wait a minute, you've got a blocked filter, come out and clean it. You've cut out the call-out, and you've cut out lead times in repairs and...
If a savvy engineer will still be going there, going, right, what else needs to be done on the site whilst I'm here? They'll create business whilst they're there.
We're not all savvy, Ben.
That's what we want, isn't it?
Yeah. Unfortunately, with new software, it's no different to going back from mechanical to electromechanical. We will have people which will not want to jump on the boat, and I completely understand because they don't want the change. But I believe, and correct me if I'm wrong, the next sort of 10 years, instead of going from mechanical to electromechanical like in the early 2000s, we're actually going to go from inverter to electronic to inverter electronic to AI IoT. Enhanced control systems. We're in the era of control. People want control. People need to know what's going on. People need to make their buildings more efficient. And that's the next piece to the puzzle, right?
Yeah. Especially when you start looking at some of these. So say some of the bigger, like say, corporate customers, let's say, I'm not going to name names, but let's say somebody who's got a large chain of shops throughout the country.
So a supermarket.
Something like that, yeah. That they really do need this level of information.
Can I butt in? Sorry, Ben. So we do a lot of work for a certain supermarket, and every Mitsubishi or Daikin, Toshiba, Panasonic, well, it's Daikin or Mitsubishi because they're the only approved units. We have to restrict every controller to 19 to 24 auto, and it has to be set to fan speed 2 or 3. And that will go into a BMS, and the BMS purely controls it. My attitude sometimes is, well, no one is actually monitoring this, even though it's there to monitor.
Yep.
Because there's thousands of shops. They can never be monitored. So going back to what you're about to say, it's going to do the thinking for them.
It's definitely going to pull the data together for them to start off with. And then they're going to start saying, oh, I've got this lovely data. How do I make it so all my shops are this efficient? Because I can see on my lovely, nice big graph that you sent me automatically that this shop are all great, and this one's not. I need you to tell me why. Don't need to go to site. Just tell me why.
Okay.
You said there's so many shops they all can't be monitored at the same time, sort of thing.
But
Well,
that's what AI is for.
Yeah, I was going to say
not that
AI
they,
will
not
filter
that they,
through
not
all
that
of
they can't be monitored. They're all monitored reactively.
Yeah.
The heating isn't working in the shop. Okay, somebody will jump on the BMS. Oh yeah, the aircon's in fault. Whereas the AI has already done that. It's already seen the heating temperature drops. It's very cold, and that it doesn't like something. Call an engineer. So actually, it contradicts what I've just said with losing work. It's actually going to generate work.
And also, you're going to get this other knock-on effect when it's actually nothing to do with the AC.
Of course.
Yeah, and you get the poor engineer going to site saying the AI's told me there's a problem with the kit. And you go,
There's a problem with the AI.
Yeah, I mean, literally to a point where literally we've had an issue where somebody say, "Well, look, something wrong with your kit," and when you get there, you say, "The big sliding doors, they normally come down, don't they?" Yeah, the doors haven't worked for the last 3 weeks.
I see.
Okay,
Or the door air heaters stop working.
you got it. You got it.
Okay.
And the engineer's being sent up because the AI said you need to do the following.
Okay.
So it's still outside influences we can't, necessarily tell. So we still need an engineer on site to go, right, I've been through this, and this. Oh, right, it's nothing to do with that. It's to do with you're parking a truck in front of the unit, which might have been the problem from day one.
Okay.
Yeah. So we still need savvy engineers.
I would have thought eventually the AI will then learn, and it's just machine learning. So that the engineer will input what the actual fault was. The AI will learn that and go, next time I'm going to remember that, and it won't be that fault.
What's quite clear, which is amazing, is it goes back to that circle.
Mm-hmm.
Evolving circle of the same products, but just enhancing them and making them better.
Yeah.
Rather than, sometimes I sort of seem to think that the refrigeration circuit is very old and we should have some phase changing material which does the cooling for us. Well, actually, that's a completely new product. Mm-hmm. Whereas, actually, the products that we've got can actually be better controlled. And the AI element actually shows that they're not being controlled properly.
Yeah. Correct. How many times have you had a nice, gentle conversation with the customers, explained to them, it shouldn't go to 30 and then straight down to 19. If you're not feeling comfortable, put it to a temperature you're feeling comfortable at. I come in there, put it at 30.
That's one of them. That's the perception of the higher the temperature, the higher the air.
Yeah.
It's no, it comes out between 35 and 45 degrees, regardless to it. But okay. So let's take the thinking away from the customer and let AI do it for them.
Or at least let's put it this way. Let's say, are you feeling comfortable? Yes or no? Right. Okay. I've taken a note of the temperature. Thank you.
Yeah. Okay.
Don't give people numbers. It doesn't always help.
Ben, in 20 years' time, if we were to sit down, you would probably say the standalone change to the industry over the last 20 years has been AI and IoT.
Yes, it chases you around the building, working out where you are in the building and changing the building temperature to suit wherever you are in the building.
I've got a robotic. I've got a robotic Hoover and a robotic lawnmower.
Yep.
Best thing since sliced bread.
I like fixing them, I must admit. I'd love taking my little robot apart.
Do you?
I've got an old Roomba.
Hold on, have you named it?
No.
Then your Hoover isn't quite AI.
Our Hoover is called Daniel, and unfortunately, it isn't AI because
I would love to put AI in that.
It still needs to be turned on.
It would think, okay, Jacob's making toast about this time. I should go and Hoover up the crumbs. It would learn.
Good point.
Stop
Good point.
it. Ben,
I like that.
Stop it.
Who's creating the dirt? Who do I need to chase?
Yeah.
And then AI turns it to, let's stop Jacob making toast.
Yeah.
Creating the problem.
Yeah. I just want a day off. Like, it will start having feelings.
Okay. All right. Going back to our peaks of summers, it still touches on the second point, and that's I've read a few books on Kaizen, and that is a method the Japanese like to use in bringing products, enhanced development. We have stock issues in the summer, and every manufacturer, in my opinion, has a part to play. Have things got better or worse? The market has grown significantly, and employment crisis, material crisis, COVID, etc. Has it always been, not just you at Mitzi, but you at York, and just overall approach? Has it always been? You work for a Japanese, I know York are American, but
they still ran what's known as JIT, just in time. So that's nothing new for me. I've done that from literally. From the beginning of my apprenticeship was always just in time. Right,
yeah, okay.
Because you don't want to hold stock. That's part of the problem. But at the same time, as the customer wants you to hold stock so I can have everything immediately. So you have to have a happy medium.
Kaizen and just in time, some advantages. Improved quality, increased productivity, greater customer satisfaction. I'd probably put my ring around customer satisfaction, because when there are delays, there's no satisfaction about that.
Yeah,
Lower
fair.
costs, increased profits, a competitive advantage,
Mm-hmm.
a sense of accomplishment, reduced waste. A few disadvantages: takes time and effort. You need the middle management. It's quite clear that you need them in place.
Yeah.
Resistance to change, costly in some cases. Management involvement is a must. Have things changed significantly over the years to get products over, or is it always something which, unfortunately, with a Kaizen JIT method, is always going to be there?
You've got some advantages in the way that things have changed. So it's about that traceability now
Okay.
as well. Yeah,
Okay,
so
so as in monitoring.
monitoring what's going on. So how do you know what things are going through the door? How do you work out that whole process constantly? Because it's constantly evolving, isn't it?
So by the looks of things, again, an alternative to Kaizen is value stream mapping, and that is when maps are used to analyse the current process, which is Kaizen, highlight problems and develop solutions. So that's something which, unfortunately, reactively has to be done as a business grows.
Yeah.
So that's what's being done.
Yeah.
Okay,
Yeah.
understood.
And you'll notice it, little things like if you ever take a cover of a unit, you'll notice there's a little barcode or a little QR code.
Yeah, of course.
That's all linking back to this constant, how do you keep on improving the quality? Well, I need to know where everything is at all times.
Understood.
Yeah?
Yeah, for
it's
sure.
The whole attitude towards quality.
So we're going to use that word AI again, but when AI is introduced into Kaizen and manufacturing and processing, things will improve if they need to improve.
Yeah.
Understood.
Because it's number crunching again.
Yeah. Okay. Interesting. Okay. So changes in the HVAC industry in 10 years' time. AI and IoT.
Mm-hmm.
Training changes. How is change? Is training is going to need to be changed for AI and IoT?
Yeah, it is.
Anything, not to say that you know something that we don't know, but any other, are there any dramatic changes? Because I believe that we're kind of there with the fridge side, and refrigeration was invented early 1900s.
Yeah.
Can you see Mr. Elon Musk dropping a curveball?
Don't think so. He seems to like the idea of heat pumps in his cars, so he's caught up with us in some ways.
Okay.
Yeah,
So we're going to stick with the next 10 years is going to be AI and control.
I think so.
So next 10 years of control.
Yeah.
Yeah, I'd completely agree, Ben. I completely agree. Right. Advice. We love advice. Let's assume you didn't work for Mitsubishi Electric, because this isn't at them at all. It's actually more of a broad spectrum of things. But direct sales, selling directly to customers, businesses, consultants. Indirect sales, technical support training and product knowledges. We've mentioned the roadshow. Demonstrations with questions and answers, which would be done on the counselling element. Any other aspects do you think that could make people have more confidence in the products? In any products, really, and this is a broad question. It's not just the aircon, because you're part of the training side of things. You see things that I don't see.
Yeah.
How can we understand better? Is apps, what? If I was to say, Ben, we've got this product that we want you to launch. What do we need to do for the competitive edge?
I think it's our end users sometimes. This is a bit of education for end users. I think might be quite a helpful thing. We're always reliant on our customer, because we're business to business.
Yeah.
Yeah, as in most people in the air conditioning industry. Yeah,
Yeah.
So we're very much reliant on this handover process being to a really high standard.
Okay.
And is that unfair? Because your average installer, he doesn't just fit one manufacturer, and you're expecting him to be an absolute pro. Maybe we could do more with that. Maybe we could do more to help with that handover process. Maybe it could be in education pieces.
So what we're saying is, actually, we've installed some equipment in your house, and homeowners need a better handover.
Well,
so that could be
education. I'm going to provide it to the word education.
So that could be education from us with videos, but it's wanting to do that.
Yeah, and you will get customers out there going, look, I've just had this new fantastic bit of kit fitted. What is it?
Yeah.
How does it work?
Okay.
What can I do anything to help improve its performance? Anything I can do to improve its efficiency? And 9 times out of 10, the answer is actually yes. And has the actual installer told them that?
So handover for air source heat pumps, this is big for, because
big time.
Because people are inheriting properties with air source heat pumps and not understanding how to use them. I know there is a lot of noise about how things should be set up and correctly installed. But you obviously get a lot of phone calls from homeowners and people that have not been handed over correctly.
Correct. We get a lot of phone calls directly from the end user, which we don't get with the air conditioning market. It's a different type of customer.
Okay. So this type of customer can go onto the Mitsubishi Electric UK YouTube channel, and there are videos where you've actually gone, I'm Ben Bartle-Ross, I'm here to help you understand what this flow fault is. Is that right?
Yes, that is. But we're working on more because the feedback has been so good.
Fantastic.
Yeah, I did a little video just before Christmas because, if I'm honest, let's just have an honest kind of conversation.
Yeah.
We had quite a busy time in the after sales team over Christmas because we had a cold patch.
Yeah.
Yeah. And let's go back to principles of the 80-20%. Yeah. So 80% of our problems came from 20% of our faults. So what were those faults? Okay, so let's say things like, let's say an E6 fault. Let's be very specific. Water flow, yeah. Okay. Communication fault because they lost the power.
Water in the isolator.
Yeah, okay. All things like that. But it could also just be as simple as, power cuts. Because it got so really cold, the power lines come down.
Of course.
So what I did was we very quickly worked with the after sales team. Right, what problems are you getting? Right, give me your top 10. Right, okay, let's take it down to the top 3. Right, let's do a video on those. And in between, I think I did that in December, just before Christmas party.
Yeah.
I knocked out a video there, and that's had, I think, 4,000 hits since then.
Fantastic.
So
Ben, I definitely think what you just said, I think we could just enhance the handover with air source heat pumps. You know why? Every Mitsubishi Electric product that's sold, let's give them a USB stick with all this, and let's tie it to the,
something like that, yeah.
Because unfortunately, not everyone has the opportunity to hand over when they're buying a new build house.
See, I think the way to do it would be via mail cloud.
And that's assuming they put it on the mail cloud, the contractor.
I really want people to use mail cloud.
Unless we use AI and we say you're no longer getting a PAR 40 controller. I'm not sure what it's called in the EcoDam, but it's the same controller visually. We're no longer giving you access to this. You must use it on Wi-Fi.
I'm not allowed to do things like that.
Yeah, but that's something which would automatically give you the information.
Yes, that's exactly what I'd love to see.
Fantastic.
Yeah, because then I can just help the customer better. I've got a problem on site. Right, let me look into that remotely. Right, okay. Right, looks like from what we're seeing here, that dip switch has been set wrong. Oh, there you go, change that. Is it all working fine? Right,
Yeah.
in fact, I'm going to tell you it's working fine.
I definitely think that with air to water heat pumps, customers, unfortunately, if you have these, you are going to have to learn a little.
And I mean, there's other manufacturers in other industries. You mentioned Elon.
Yeah.
Yeah. If you get a power wall, it won't switch on until it's done its little handshake across the internet. Yeah. To make sure everything's correct before it switch on. When I saw that, I got a little bit jealous.
Okay.
Because
it has to be online.
Mm-hmm.
Yeah. Obviously, mainly most people with power walls have a need for reducing their carbon footprint, going green, even also sometimes going off grid.
Yeah.
And with them sort of customers is what I would call a blue in the disc system, someone that's very technical. I know you're aware of the disc system because all manufacturers use it for sales and understanding of people. And those blues tend to be quite intelligent and like to do their research. So an air source heat pump for someone that's blue is fantastic. But someone that is red and yellow, like me quite often, I want it working and I don't care how it's done, just get it working.
Yeah, it's not my problem.
It doesn't work sometimes. But if I'm definitely on the app and I put an E6 fault code in and there is a video of Ben or an animation showing a demonstration of what it could be, it ticks that box.
Yeah, how quick can I get that information?
Wonderful.
Get it fixed, get running. Yeah.
Just to finish on Ben, you have a lot of people that you train and a lot of people that are upcoming. If you were to speak to one, there's also a lot of people online that film themselves working, engineers. If you were to give them one piece of advice as they embark in the aircon industry, for me, it's resilience. Just stay resilient, don't give up. You'll always get there eventually. What sort of advice would you sort of give them to sort of add that feather to their hat?
Don't be scared to learn. Keep on learning. Yeah, we're in a changing environment, and it's going to keep on changing. Yeah, we've got playing out with different refrigerants, playing out with different ideas, different ways of being more green. This is an ongoing thing. You cannot sit there and stagnate saying, I know what I'm doing. You've got to keep on being a student. Sorry.
Perfect. Thank you very much, Ben.
Thank you.
Ben, I'd like to say reach out to Ben, but you can't. So Mitsubishi Electric have a very good YouTube channel. Check it out. what we've covered here today, he has honoured his word, and there is a lot of training, a lot of help there. As a thank you, Ben, since I've been in it since 2007, you have been a part of me being an engineer. And there's probably a lot of people out there which would never say thank you. I know there's a lot of people which will always say, Ben Bartle-Ross, he's a gem. So thank you for your service to the industry. If we could give you an OBE, we would. Maybe the king is listening. But yeah, thank you very much. He's straight to the point. Every video he gives, he shows passion. Check him out and check out Mitsubishi Electric's videos.
Thank you, Jacob. And thank you for keeping on being such an enthusiast about our industry, because we need it.
Thank you very much. Right. If you like the video, like, subscribe, and let us know what you think.